Hello, in this video we're going to discuss systems of linear equations and partial fraction decomposition. This is one of those sections where the ideas are more procedurally driven. That means we need to practice more. Okay. So learning objectives are understand the systems of linear equation, understand as in what it means to have systems of linear equation, and what it means to have a solution, no solution, or infinite number of solutions. And be able to solve systems of linear equation using matrix, and be able to solve using elimination method. Then we're going to also look at decomposing fraction expressions. So let's talk about what systems of linear equations are. So systems of linear equations, there are three possible outcomes when solving a system of two linear equations. So here let's focus on the language. A system means that it is a system contains two linear equations with two variables. Okay, so a system, one system will have two linear equations, and it can also have 3 and 4, and we'll look at the 3, in a second. So a system means we have two linear equations. So two linear equations, combining them creates a system. Okay, and two linear equations with two variables, such as x and y. So when solving for a system of equation, we can have one solution. That means the two linear equations intersect at one point. So this is one solution. But we have a point, right? X, let's say x1, y1. We have a ordered pair. This x, y does not mean we have two solutions. This point right here is one solution. Okay. And no solution, or inconsistent sometimes we'll say, when we have parallel lines. That means that slopes are same. So when we have a system of linear equation where each linear equation has same slope, as you can see here, right? Then these two lines will never intersect. Therefore, there's no solution. And third possible outcome is system linear equation that have infinite many solutions. So you can think as they overlap. Okay, they overlap. So there's one, and essentially they're identical lines. So that's why we have infinite number of solutions, because they have infinite number of points where we intersect. Okay, so this is when we have two linear equation with two variables. What happens when we have three variable linear system? So linear equation with three variables is represented by as a plane in 3D space. So when we have three equations, we have 3D plane. So here's the possible outcomes. So we have three scenarios. Whereas we have consistent system, we have one solution. Which means that three planes intersect at one point. Now second scenario is with infinite number of solution. But for infinite number of solution for three variable, three equation, there are two different scenarios where three planes intersect in one line, if it's still infinite number of solution, where all three planes overlap. So we have essentially same three planes. Inconsistent system means again no solution, where all planes are parallel to each other, or they intersect with only two planes at a time, like this. Then there is no solution. Because in order to have a solution, all three planes must intersect at least one point. Okay, so we're only going to look at two linear equation in a system or three linear equation in a system in this class. So this is two possible, in terms of systems of linear equation, two possible way we're looking at it. So let's see how we can solve for it. So one method is called Gaussian elimination, or also known as using matrix. So we have to know how to solve for it using both methods, matrix and regular elimination, which we're going to look at in few pages. Okay. So again, it is not just about finding the solution. We're really building our critical thinking skills and practicing patterns using this matrix. Okay, so don't only focus on just outcome. We're really training our thought process, diligence, and patience to using this method and using these solving skills. Okay. So we're looking at Gaussian elimination. So first we need to be able to express systems in an equation using augmented matrix. Okay. So this is how this is the steps. So I wrote here so you can read it in overview note, but let's just look at an example. It's quite straightforward. So when we write a matrix, we draw a big bracket and a vertical line. So here I'm going to write coefficients of x and coefficients of y, and here will be just the numbers itself. So coefficient of x comes from here, so I'm going to write 2 and -4 here. And then coefficients of y is 1 and 6. And lastly, these are just numbers, so 5 and 12. So this right here, let me write in just one color. So this, if we see this matrix, is called augmented matrix. This represents these two system linear equations. Okay. So let's try this one. Let's just, again, we're practicing writing in matrix. So I like to write it x, y, z just in the beginning, the top of the matrix, to prevent any mistakes. But eventually you don't have to once you get used to it. So this is 1. So we have 1, 1, -1, 1, 1, -1. And also -1. We have 4, -3, 2, 16. 4, -3, 2, 16. Then we have 2, -2, -3. 2, -2, -3. And 5. Okay. So now, once we write in a augmented matrix, we need to do what's called row operation, right? We have 3 rows here, 3 rows. Here we have 2 rows. We need to do what's called row operation to solve for systems of linear equation. So to solve using Gaussian elimination, we have to, again, do row operation to convert matrix to raw echelon form. And again, I'll talk about this, what it is. In this form, there are ones down, number 1, down the main diagonal of the matrix. We can use this matrix and back substitute to solve for it. So what do I mean by raw echelon form? That means we need to, our goal is to write a matrix. We can convert to 1, 1 diagonal, and there'll be some number here, some number here. We don't know what those numbers are. Those are depends on the problem. Or we can have also 1, 1, 1, 0, 0, 0, some numbers. Number. So our goal is to have ones in the diagonal, like here, but also zeros here. Zeros here. Okay. So left bottom side of the diagonal of ones, we should be zeros. Okay. So we can perform following row operations to convert coefficient matrix to raw echelon form and do back substitution to find the full solution. So these are the possible row operations we can do. We can always interchange the rows, row 1 and row 2. We can change the location of each row. And we can also multiply a row by a constant, a number. We can multiply a number to just one row. We can also add a product of row multiplied constant to another row, right? So if I have a row 1, I can add constant multiply row 2 and add into it. So yeah, these, again, will make more sense when I do an example next page. So let's solve this by Gaussian elimination. Again, you need to be able to you have to know how to use Gaussian elimination using matrix. Okay, we're practicing the skills, the procedure, right? It's not just about getting the right answer. We're practicing these skills. So first we write a matrix. And let me note here, we want to make it 1, 1, 0. This is our goal. Okay, and it'll be some number here, some number, some number. Okay. So first, I want to make this 4, 1. What can I do? Okay, there are several ways to go about row operation. But first, let's think as this is row 1 and row 2. I'm going to switch row 1 and row 2's location. Okay, so that's a allowable row operation. So that means I'm going to have 1, negative 3, negative 1, 4, 3, 11. So now we're good because we have 1 here. Okay. Okay, so this one's good. So we go this first, then we have to look at this. This is second step, and this is third step. So we always have to go in that order. So we made this 1, that's good. Now our goal is to make this 4, 0. So we always have to go in that order. So order is 1, 0, then 1. If it was 3 by 3 matrix, we have 1, 0, 0, 1, 0, 1. So we must follow this order. So our goal is to make this 4, 0 now. How can I do that? So now pay attention. Now this is row 1 and this is row 2, right? So what I'm going to do is now row 2 will be equal to negative 4 row 1 plus row 2. Okay. So why did I do that? Because if I multiply negative 4 here, then if I add to here, I get 0, right? So that's what we're doing. So in this new matrix, well, updated matrix, first row stays as it is. But only second row changes to, I'm going to multiply negative 4 to row 1 and add to each row 2. So negative 4 times 1 gives me negative 4. Then negative 4 plus 4. 4 is here. Then again, negative 4 times negative 3 gives me positive, well, I mean, not right, positive, will be 12 plus 3. And negative 4 times 1 gives me negative 4. Negative 4 plus 11. So let's just do the addition. We have 0, 15, oops, this is negative 1, I'm sorry. This is negative 1, I've copied wrong. So this is actually positive 4. So we have also 15 here. Right. So this matrix is after this row operation right here. Now we're good. We have 1 and 0 here. Now we have to make this 1. How can we do that? We can do another row operation where R2 now becomes 1 over 15 times R2. I can just multiply 1 over 15 to all this row 2 numbers. Then this number will become 1, right? So let me just do that again. Row 1 stays the same. Just copy it. Keep doing this negative 1 here. Negative 1. Then I get 0. 15 divided by 15 gives me 1. 15 divided by 15 gives me 1. So now we're at this point where we have 1, 1 in diagonal, and 0 here. So we met our goal. Now we need to translate this into our final answer. So what is final answer? This tells us that, let's rewrite to our equation. This says x minus 3y equals negative 1. This tells us that 1y equals 1. So we let have y equals 1. So then I can plug this y equals 1 to right here to solve for x. So then we have x minus 3 equals negative 1. X equals 2. So our solution is 2 comma 1. So this one has a solution, and that solution is 2 comma 1. That means that this equation, these two systems, a system equation that has two linear equations, and these two linear equations intersect at 2 comma 1. Okay. Okay, so I'd like you to try this on your own. Again, pause the video, right, and try on your own. And again, take your time. This is one of those sections again, just like all the sections, you have to actively try to master these skills. So pause the video, take your time. I know how much of your time you need. Try your best and come back, and you can see how I did it. Okay, so first writing matrix 2, 1, 1, 4, 2, 6. Okay. So first we're to make this number 1. Okay. So how do we do that? Well, let's make row 1 equals 1 over 2 divided by 1 over 2 times R1. So now old R1 is becoming new R1. What's new R1? 1 over 2 times R1. So just essentially multiplying half all the way here. So then I have 1, half, half. Second row, we haven't changed it, so it stays as it is. So this one's good now. Now we have to make this 4 0. Okay, how do we do that? Again, we cannot subtract just 4 in entire row. We cannot do that. We can only add another row, or we can multiply a number to another row and add to it. So now row 2 then will become, we're going to, well, what do I have to multiply here to get? What do I have to multiply to 1? Then, so that if I add to 4, I get 0. Negative 4, right? So I'm going to do row 2 will become negative 4 times R1 plus R2. Okay. So again, we're only changing R2. So row 1, just stay as it is. Copy what it was from the previous step. Now for row 2, we're going to multiply negative 4 to 1. So negative 4 times 1 gives me negative 4. Plus R2, which was 4. So just add 4. Now negative 4 times half gives me negative 2 plus 2. Now negative 4 times half gives me negative 2 plus 6. So then let's simplify this. Then I have 1, 1 half, 1 half, 0, 0, and positive 4. Now here, we want to have 1, but it tells us 0, right? So this tells us that 0, 0y equals 4, which is claiming that z equals 4. But g is never equal to 4, right? So this is actually false. So this equation actually happens to have no solution. Okay. So this has no solution because this is saying that 0y equals 4. Okay. So now let's look at 3 by 3 matrix. Again, the order in which we go about obtaining row echelon form. So we have 1, 0, 0, 1, 0, 1. This is the order we're following. So let me write that. We want to make this 1 first, then 0, 0, 3, 4, 5, 6. Okay. So let me write in matrix form first. So we have 1, 1, negative 1, negative 1, 4, negative 3, 2, 16. 2, negative 2, negative 3, 5. So first, 1's good, right? We already got here. So 1's good. So now we have to make this 4 0. Now here we have a few options. We can multiply a number to R3 and add to it, or multiply a number to R1 and add to it. Right? Either one's fine. But as long as you don't make any arithmetic mistake, it's fine. So R2, I'm going to just do negative 4 times R1 plus R2. So that means I'm going to multiply negative 4 here to the entire R1 and add across in R2. So in my new matrix, updated matrix, well, R1, we're not changing R1 right now. So stay as it is. And R3 also not changing, so I'm just going to copy it. Only R2 is changing for in this matrix. So negative 4 times 1 gives me negative 4, plus 4 gives me 0. Negative 4, again, negative 4 times negative 1, negative 4 times 1 gives me negative 4. Now add to here, negative 3. Gives me negative 7. Negative 4 times negative 1, positive 4 plus 2 gives me 6. Again, make sure you're keeping track correctly. Negative 4 times negative 1 gives me positive 4 plus 16 gives me 20. Okay. And it's always helpful to double check, right? Negative 4 times 1 plus 4 gives me 0. Negative 4 times, we can also do negative 4 times 1 gives me negative 4. Negative 4 plus negative 3 gives me negative 7. Negative 4 times negative 1, positive 4 plus 2 gives me 6. Negative 4 times negative 1 gives me positive 4, plus 16 gives me 20. So this is good. Okay, so make sure you don't make any mistakes, because one mistake will result in a wrong answer. So then with this 2, okay, so let me do this. 1's good, 0's good. Now we want to make this 2 0. So what do? R3. Now R3 will be negative 2 times R1 plus R3. Because if I multiply negative 2 here to 1 and add across, this will be 0, right? So let's write that. Again, row 1 stays the same, so I'm going to copy it from previous step. Row 2 also stays the same. Now row 3, this will be 0. And negative 2 times 1 gives me negative 2. Negative 2 minus 2 will be negative 4. Negative 2 times negative 1 gives me positive 2. Plus negative 3 gives me negative 1. Negative 2 times negative 1, positive 2 plus 5 gives me 7. Okay. Okay, so that's good. So now we want to make this 1. Okay. So in order to do that, we can just do R2 equals R2 over negative 7. So again, everything else is the same. 0. Oh, let me write the third row first. So negative 7 divided by negative 7 gives me 1. 6 divided by negative 7 gives me negative 6 over 7. And negative 20 over 7. Okay. Okay. So now our goal is to make this 0. Now here, since we already have 0 here, right, we cannot add row 1 to row 3 anymore, because then this one will be added to 0. They will make it not 0 anymore. So here, in order to switch R3, we only have one choice. We can only add row 2. So we can, let's do this. This will be 4 times row 2 plus row 3. Okay. So then 4 times 1 gives me 4. If I add to negative 4, gives me 0. So let me write that. So 1, 1, negative 1, negative 1, 0, 1, negative 6 over 7, negative 20 over 7. So 0, 0. Now 4 times negative 6 over 7 gives me negative 24 over 7. Negative 24 over 7. So let me actually write this part a little bigger so I can do step by step. So we have negative 26 over 7 minus 1 over 1 is same as 7 over 7. To have a common denominator, I'm going to write it like this. Oops, 24, sorry. Let me write that better. Negative 24 over 7 minus 7 over 7. Then here, then let's do 4 times negative 20 over 7. What do we get? Negative 80 over 7. Okay. Plus 7 will be 49 over 7, right? So let's calculate this part in the next step. Again, everything else stays the same. This right here now is negative 31 over 7. This is also negative 31 over 7. Okay. So on the last step, right here, what we're going to do is row 3 will be now negative 7 over 31 times row 3. We're going to multiply the reciprocal of this to make this one right here. Okay. So let me actually just erase it and do it here. So then this now will become 1. This will also become 1, right? Because I multiply reciprocal. So we have 1 and 1. So this tells us that 1y equals 1. So this tells us y equals 1. The second row tells us that, oops, sorry, this is not y. Since we have third equation, we have z here. So we have, this tells us z equals 1. Second equation tells us that 1y minus 6 over 7z equals negative 20 over 7. First equation tells us that x plus y minus z equals negative 1. Okay, so we can plug 1 here to solve for y. Then y will be this is 1. Then if you solve for y, y will be negative 2. Oh, let me double check. Let me actually add so I can double check. So we have y minus 6 over 7 equals negative 20 over 7 then y is negative 20 over 7 plus 6 over 7, which is negative 14 over 7, is negative 2. So y is negative 2. Z is 1. Okay. So then we can plug those numbers. X minus 2 minus 1 equals minus 1. What is x? This would be negative 3. If I add plus 3 both sides, you get 2. So our final answer for this problem is negative 2. Oops, sorry. Positive 2, negative 2, comma 1. Again, this is one solution. This entire thing is one solution. This is not 3 solutions. One solution. Okay. Okay. So as you can see, the row operation takes practice. Okay. So again, please, if you want to practice with me in office hours, please come to office hours. I'll be very happy to help you. Okay, so this one I like you to try on your own. Again, I just want to give you extra practice before you try the homework on your own. So answer for this one will be 4 comma negative 3 comma 1. So again, try on your own, set up the matrix, do the raw operation. Okay, and try. Okay, so make sure you get these answer. Okay, and if you don't get this answer, then it means you're either making some mathematical mistakes, calculation mistakes, or you're making raw operation mistakes. So let me review the allowable raw operations. We can just interchange the rows, it's like the location. We can also multiply a number to entire row. And we can add a product of a row multiplied by a constant to another row. Okay. So as we did it here, right? We multiply negative 4 to row 1, then add to row 2. That's possible. But we cannot just add simply just numeric one number to entire row. That's not possible. So keep this in mind, the 3 row operations, and practice these Gaussian elimination. Okay. So again, I would really like you to pause the video so that you can get this 4 comma negative 3 comma 1. Okay. Okay, now try this problem. Okay, video problem. Again, this requires many repetitive practice. Pause the video, try this 2 by 2 matrix, two equations, 2 linear equations, and type your answers, type your solution in Canvas. Okay, so you type. So I mean, I can tell you this, that this has a solution. Okay, so type what x equals, what y equals in Canvas. Okay. So now we're going to look at another way of solving. Okay. Again, I really want to emphasize it's not only about getting the right answer. Of course, you should practice enough so you'll not make mistake to get right answer. But we're just practicing the skills of these 2 different methods. The one we just saw, Gaussian elimination. Now we're going to look at just elimination. Okay. So again, both skills you need to know, and you need to know how to do both ways for the quiz and the homework. Okay. So I understand that some of you might be comfortable with one way than another, but it's not just about the comfort. Right? Again, it's the thinking and the mental action requires you to develop as you learn both skills, as you practice both skills. So let's look at method of elimination. So when 2 variable equation, Okay, obtain the coefficient for x or y that differ only by sign by multiplying all terms. Add equations to eliminate one variable. Solve equation obtained in step 2. Back substitute. This is similar to the back substitution part, is similar to the Gaussian elimination when we use matrix. And check the solution. Okay. So again, all these steps, I'll just write it out so you can refer to back later. But again, I think these are more understandable when you look at the steps. So elimination means that we want to eliminate one variable. So we can choose. Here we have two equations, right? You can choose either x or y to eliminate. And sometimes it's easier to pick one or the other. It depends on the equation. But whatever you choose to eliminate, as long as your steps are correct, calculations are correct, you'll get the same conclusion. So here I'm going to multiply 2 to equation 1. So then I get 4x plus 2y equals 10. And second equation, I get negative 4x plus 6y equals 12. Then I'm going to add across. So as you can see, when I add, 4x and negative 4x cancels out. So we just eliminated x. So then I get 8y equals 24. So that tells us that y equals 24 over 8, which is 11 over 4. So now that we know 11 over 4, I can plug y into either here or here to solve for x. And both equations should give us same x value. Okay. Okay, so why don't I plug it here? Then I get 4 times 11 over 4 plus 2y equals 10. Oops, sorry. Plug it wrong place. 11 over 4. So I get 4x plus 22 over 4 plus 10. Oops. Not plus, equal, sorry. So then 4x equals 10 minus 22 over 4. So let's common denominator give us 40 over 4, 22. 4x equals 18 over 4. X equals 18 over 16, which is 9 over 8. So our solution is 9 over 8, comma 11 over 4. It has one solution, and this is the one solution. Okay. So this is how elimination works. Let's get another example. Again, we can choose. So I'm going to choose to eliminate x, so I'm going to multiply negative 3 here. Then I get negative 15x. Or actually, let's do positive 3. Well, 15x minus 3y equals 9. Then I get second equation. Then we add across. I get 0. But here also, y also get eliminated. So this tells me that 0 equals 0. And 0 equals 0 is always true, right? So here we have infinite number of answers. That means that these two equations are actually the same equations. They overlap. If we were to graph, they overlap. Slope is same, y-intercept is same, they overlap. Okay, and we can actually solve for that equation. So if you look at this one, 5x minus y equals 3, we can solve for y. So y equals 5x plus 3. This is the equation, the linear equation. They overlap. So both of these equations is essentially this. Slope 5, which is also same as constant rate of change, and y-intercept is 3. Okay. Let's get another one. Similarly, again, we can choose to, let's eliminate x. So I'm going to multiply negative 2 here. Then I get negative 6x positive 4y equals negative 10. 6x minus 4y equals 12. So let's add across. I get 0. 0 equals 2. So this tells me that 0 equals 2, which is false, right? So this is how a no solution will look like when we do elimination method. No solution. That means these two lines are parallel to each other. Maybe something like this. Parallel. No intersection. Okay. Now when we do 3 by 3 equation, okay, we have to be, of course, it's 3 by 3 equations, so we have to be a little more careful in terms of not making mistake, right? So let's look at this example. So 3 by 3 equation. So first, what I like to do is actually write down what we're going to eliminate. Okay. So I'm going to eliminate y. Okay. So I have 3 equations here. Equation 1, 2, 3, right? So what I'm going to do is I'm going to pair. I'm going to have 2 pairs of equation. So for first equation and let's say second equation, I'm going to eliminate y. Okay, so let's write the first equation. And I'm going to multiply 3 to first equation. Okay, so I'm going to multiply 3 to first equation. 3 times first equation gives me 3x plus 3y minus 3z equals negative 1. And second equation, we can just write it as it is. Equals 16. And we add across. And because we're eliminating y should be gone. And as you can see, 3 plus negative 3 gives us 0. So we get 7x minus z equals 15. Now, what we just came up, so let's label this as fourth equation. We just came up with fourth new equation. So let's keep that aside. Now, we're still eliminating y. So now we're going to look at equation 1 and 3. And you can also do 2 and 3. Okay, it doesn't matter as long as you eliminate y. So now in order to eliminate y in third equation, I have negative 2y. That means I have to multiply 2 to first equation. So 2 times first equation gives me 2x plus 2y minus 2z equals negative 2. 2x minus 2y minus 3z equals 5. So I add and get 4x minus 5z equal 3. Now what we have here is fifth equation. Okay. Now we're going to rewrite fourth. Now using fourth and fifth equation, we have to eliminate another variable that is not y. So again, you can choose either now we have x or z, right? So I'm just going to eliminate, I decide to eliminate z. So in order to eliminate z on here, I need to multiply, I need to have a 5 here, right? Well, negative 5 in fact, so I'm going to multiply negative 5 to equation 4. And fifth equation, I'm going to just copy it as it is. So then I get negative 35x plus 5z equals negative 65. Okay. Actually, I made a mistake. I don't know if you guys caught that. Wow. I did the calculation right, but I didn't write it right. I think I set it 3 here because I multiplied 3, right, to negative 1. Then when I add it, I should get 13. 13. So then 13 times 5, negative 5 gives me negative 65. Okay. So then I get 4x minus 5z equals 3. Okay, 5z. So let's add across and I get negative 31x equals negative 62. Again, we're eliminating z now, not y, z. This is second step, second part of the doing this problem. Okay. So then x we get as 2. So x is 2. So in terms of our final solution, we have x is 2. And we have to still find y and z, right? X is 2. So in order to find y, we can just plug into one of fourth or fifth equation. Okay. Again, doesn't matter. Both of them should give us same answer. Okay. So let's just plug in here. Then 4 times 2 minus 5z equals 3. So a minus 5z equals 3. Okay. So z is 1. So z is 1. So now we know 2 and 1. We can plug it right here. We'll get 2 plus y minus 1 equals negative 1. Okay. So then y, if you solve for this, is negative 2. So our final answer is this right here. Okay. So for elimination by 3 by 3, okay, it is important to declare what we're eliminating first. Then we come up with fourth and fifth equation. And using the fourth and fifth equation, we eliminate another variable other than the one we eliminated earlier. Okay. And back substitute this to find other variables. So as you can see, once you get one number, other numbers just plug back in to find the unknown variable. Okay. So let's look at one more example. So same idea here. Okay. We have equation 1, 2, 3. Again, we pick. I'm going to eliminate z because as you can see, if I add first and two equation, I get 0 for the z part, right? So that kind of make it a little simpler. But again, whatever you choose is fine. You can choose to eliminate x or y. As long as your calculations are correct, you get the right answer. So for first and second equation, just add across. So I have x minus 2y minus z equals 8. 2x minus 3y plus z equals 23. So we add across, we get 3x minus 5y, z's go away, equal 31. Now this is our fourth equation. Okay, fourth equation. Now pick another pair. Let's pick first and third. First and third. Now in order to eliminate this z with 5z, we have to multiply 5 to first equation. So 5 times 1 gives me 5x minus 10y minus 5z equals 40. Then we get 4x minus 5y plus 5z equals 53. So on that add across, we get 9x minus 15y equals 93. So this is our fifth equation. Okay, oops. Let me draw a step here. Now, let me come back here. Fourth and fifth equation. Again, now we have to eliminate different variable, not z. You can pick or x or y. Yeah, so let's just do x. Eliminate x. So then I need to multiply negative 3 here, right? To get it cancel out with 9x. So let me use different color actually. So negative 3 times fourth equation gives me negative 9x plus 15y negative 93. And fifth equation is just 9x minus 15y equals 93. So we add, actually we end up getting 0, 0 equals 0. This is always true, right? So this one actually has infinite number of solutions. Infinite solutions. Okay. Okay. So again, it's important for you to be able to do both method, elimination and matrix. And people have different preference, right? Some people like matrix because matrix you don't have to do just two main part of eliminating x and z. But some people just prefer elimination, regular elimination. Okay, again, it depends. But the important thing is you have to know both method. Okay. So on the part 2 of the video, I'll be doing the partial fraction decomposition. Okay. So make sure you review this video. Then also watch the part 2, which I'll be doing partial fraction decomposition, which actually be using some of these skills as well.